independent events. Find P of Q and R. So, an independent event or independent events are occurrences where the outcome of the first event does not affect the outcome or the probability of the second event. If A and B are independent events, then P of A and B is equal to P of A times P of B. So in knowing that, to find P of Q and R, what we're going to have to do is P of Q times P of R. So we're going to do 1/4 times 2 over 3. And 1/4 times 2 over 3 is going to equal 2 over 12. Because 2 times 1 equals 2, and 3 times 4 equals 12. So we have 2 over 12. And we're going to reduce that by the greatest common factor of both of these, which is the GCF. Let's write that G better. The greatest common factor of 2 and 12 is, you guessed it, 2. So we're going to divide both the numerator and the denominator by 2. And 2 divided by 2, let's just redo that all together. The greatest common factor is 2. So GCF is 2. 2 divided by 2 equals 1. And 12 divided by 2 equals 6. So our simplified fraction is 1 over 6. That is our answer for the probability of P of Q and R. The next one is P of Q equals 0.6 and P of R equals 0.9. So we're going to multiply 0.6 times 0.9. And 9 times 6 is 54. We're multiplying this, so 54. And for the placement of the decimal, we count how many numbers we have behind the decimal in total. So it's one number behind the decimal here and another number behind the decimal there, and 1 plus 1 equals 2. So that means we need to have 2 numbers behind our decimal. So P of Q and R is equal to 0.54. Great job, everybody. Next, S and T are mutually exclusive events. Find P of S or T. So if there's a mutually exclusive event, let's see what that means. When two events cannot happen at the same time, they are mutually exclusive. For example, rolling a 2 or a 3 on a number cube are mutually exclusive events, because if you roll a 2, then you cannot roll a 3. You only have one possibility or outcome. Two events that cannot occur at the same time. So here, when we have two events that are mutually exclusive or two events that cannot occur at the same time, to find P of S or T, we use this formula. P of A or P of B equals P of A plus P of B, meaning we're going to add the two probabilities together. So here we're going to do 5/8 plus 1/8, which is going to give us 6/8. So to add fractions, we need to have common denominators. And in this instance, we do have common denominators. They both have a denominator of 8. So meaning we can add the numerators. We get 6 and we keep the denominator the same and we get 8. To simplify, we have to find the greatest common factor of both the numerator and the denominator. And in this instance, it is 2. 2 goes into 6 as well as 8. So we're going to divide the numerator by 2. So 6 divided by 2 is 3. And we're going to divide the denominator by 2. And 8 divided by 2 is 4. For this next problem, since they're mutually exclusive, we're adding the two together. So P of S, 12% plus 27% is equal to 39%. That's our answer. So we can write that as P of S or T is equal to 39%. Keep going. A standard number cube is tossed. Find each probability. So here we have P of 3 or odd. Since you can both roll a standard number cube, or some people will call it a dice or a die for a singular one, 3 or odd, since you can roll both the 3 and the odd number at the same time because 3 is odd, this is not a mutually exclusive event. So we're going to use this formula. P of A or B is equal to P of A plus P of B minus P of A intersection B. All right. The intersection of something means two sets that have something in common, that have terms in common. So let's look at this. So we're going to name each set. So for a standard number cube, we know that the possible outcomes are 1, 2, 3, 4, 5, and 6. These are all of the possible outcomes when you roll a number cube or you roll a die. For here, we're going to make P of 3. We're going to list out the set of the probability of rolling P of 3. All possible outcomes of rolling P of 3 is simply just going to be 3. There's only one number in that set. Now for P of odd, the possible outcomes to roll an odd number would include a set with the numbers 1, 3, and 5. Now, for P intersection, so we're going to say for P of 3 intersection odd, let's make the 3 red and the word odd green. Intersection means the terms that are common within each set. So here, the only terms that are common within each set are 3. So P of odd P of intersection odd just has the set of 3. So now let's use our formula, which is P of 3 plus P of odd minus P of 3 intersection odd. So let's write it out. P of 3 plus P of odd minus P of 3 intersection odd. So P of 3 is going to equal 1, because the possible outcomes are 1 out of 6. So the possible outcomes out of the total outcomes. So 6 total outcomes and only 1 event. And then plus 1, 2, 3, 3 over 6 minus 1 over 6. Now remember, I'm getting this from the sets. 1 out of 6, 1, 2, 1, 2, 3 out of 6, and just 1 out of 6. So that gives us the answer of 3 over 6, which is reduced to 1/2 because the greatest common factor is 3, and 3 divided by 3 is 1, and 6 divided by 3 is 2. All right, the next one.